and a warm welcome to one and all present here. I'm extremely elated and privileged to welcome you all once again. Let me share a brief introduction about our two conveners and one coordinator for our FDP program. Let's see about them one by one. First, let me introduce Dr. S. Kutirani ma'am. She is a professor and dean of the School of Physical and Chemical Sciences at B.S. Abdur Rahman Crescent Institute of Science and Technology, which is deemed to be a university. She has completed her bachelor's, master's, and MPhil degrees in chemistry from the University of Madras. She completed her B.Ed education at Annamalai University. She pursued her MBA degree in Education Management from Azhagappa University. She gained her PhD in Catalysis and Kinetics from Anna University. She started her career as a lecturer in the year 1991 at the Department of Chemistry, B.S. Abdur Rahman Crescent Institute of Science and Technology. She has become the Dean of the School of Physical and Chemical Sciences since 2015. She has published several research articles in high-impact factor national and international journals. Her research areas include catalysis and kinetics, synthesis and characterization of Schiff-based complexes, and synthesis and characterization of polyoxometalates. Under her supervision, many students have completed their PhD. She is currently guiding 12 MPhil scholars and 6 PhD scholars for the doctorates. Now, let us see about our second convener, Dr. D. Ishamurthy sir. Dr. D. Ishamurthy sir is currently a professor and head of the Department of Chemistry at B.S. Abdur Rahman Crescent Institute of Science and Technology, which is deemed to be a university. He completed his PhD from Madurai Kamaraj University. He worked as a postdoctoral fellow at National Sun Yat-sen University, Taiwan from 1998 to July 1999. He was awarded Young Scientist Fellow by Tamil Nadu State Council for Science and Technology. He received Rainbow Scientist Award from South Korea. He was also awarded Summer Research Fellowship by Indian Science Academy. His areas of research interest include coordination complexes, catalysis, solar cells, etc. Under his supervision, many students have completed their PhD. He is currently guiding several PhD scholars and master students. He has published several research articles in high impact factor national and international journal. Now, let us hear about the coordinator of our FDP program, Dr. N. Vasimalai sir. Dr. N. Vasimalai sir is now working as an assistant professor, selection grade at the Department of Chemistry, B.S. Abdur Rahman Crescent Institute of Science and Technology, which is deemed to be a university. He has completed his bachelor's and master's degrees in chemistry from Vivekananda College, Madurai. He received Best Student Award for both the degree period. He completed his MPhil and PhD degrees from Gandhigram Rural University, Dindigul, under the guidance of Professor Abraham John. During his PhD, he has received UGC JRF and CSIR SRF fellowships from Government of India. After the completion of PhD degree, he worked as postdoctoral fellow at the National Cheng Keng University, Taiwan. Then he received globally renowned Marie Curie Fellowship in Europe and worked at the International Iberian Nanotechnology Laboratory, Portugal from 2015 to 2018. He has published more than 30 research articles in high impact factor international journals and has authored 4 book chapters. One of his articles has been highlighted in Nature India. The main highlight is he is the first author or corresponding author of all his publications. Now he is guiding 4 PhD students and several master students. Moreover, he is a PhD co-supervisor of Malaysian student in University of Mara, Malaysia. He is an editor of Mayfeb Journal of Chemistry, Canada, and reviewer of ACS, RSC, Elsevier, Springer, and Wiley journals. He has delivered several talks in national and international institutions. His field of specialization has been focused on the synthesis and characterization of fluorescent metal and metal oxide nanoparticles and the biosensors and biomedical application. Recently, he has developed a technology for 1-minute synthesis of highly fluorescent copper nanocluster and developed a smartphone-aided paper-based kit for on-site monitoring of bio and toxic chemicals. He has a research collaboration with several countries including Portugal, USA, Germany, Spain, Malaysia, Japan, Taiwan, and Australia. So, that's all. Unity is strength. Alone, we can do little, but together, we can do so much. The word team suggests that together, everyone achieves more. Yes, behind every successful event, there exists an unseen combined team effort performed by a group of dedicated people behind the scenes. But we don't want them to be behind the scenes anymore. Let's look on to them. They are the research scholars involved in the student committee. Mr. M. Chandru, doing PhD under the guidance of Dr. S. Kutirani Ma'am, Professor and Dean School of Physical and Chemical Sciences. Mr. V. Hari, doing PhD under the guidance of Dr. Revati Purushothaman Ma'am, Associate Professor. Mrs. T. Lakshmi, doing PhD under the guidance of Dr. Noorahman Sir, Assistant Professor, Senior Grade. Mr. M. Marudupandi, doing PhD under the guidance of Dr. N. Basimalai Sir, Assistant Professor, Selection Grade. Mrs. J. Immaculate Mercy, doing PhD under the guidance of Dr. N. Basimalai Sir, Assistant Professor, Selection Grade. Ms. F. Aisha Begum, doing PhD under the guidance of Dr. S. Bhagavati, Associate Professor. Mr. S. Gokuleshwaran, doing PhD under the guidance of Dr. N. Basimalai Sir, Assistant Professor, Selection Grade. They are our second MSc students involved in the committee. Mr. K. Venkatramanan, Mr. R. Abhilash, Mr. P. Gunasegaran, Mr. V. Venkatesan, Ms. K. Samira Khatun, Ms. Archana, Ms. J. Nishat Begum, Mr. Mohammed Ibrahim, Mr. M. A. Ashkar, Ms. G. Renita Mary, and Ms. Khatija Sahiba Jahid. Thank you one and all for your unflinching support.
Okay, Winget, please stop screen. Chief Guest Sir, please share your slide. Dean Madam, HOD Sir, can we start the program now?
Yes, you can
okay,
start.
Sir. Chief Guest Sir, can I start the program now?
Yeah,
sir,
yes,
mic. Okay, sir. Thanks a lot, sir. Please share your screen, sir.
Yeah, doing.
Thank you, sir. So, respected Dean, School of Physical Chemical Sciences, Dr. S. Kutirani, ma'am. Respected Head of the Department, Dr. D. Iswaramurthy. And today, Chief Guest, my Professor, Dr. R.Karvembu, Professor, Department of Chemistry, National Institute of Technology, Trichy, Tamil Nadu. And dear participants and my students. So good afternoon to all. On behalf of Department of Chemistry, B.S. Abdur Rahman, Crescent Institute of Science and Technology, I welcome you all for the last day, that is the 14th day event of today FDP program. So now I hand over the session to Aisha.
Good evening, everyone. On behalf of the Department of Chemistry, B.S. Abdur Rahman, Crescent Institute of Science and Technology, I take pleasure and feel privileged to welcome you all for the 14th day session of our FDP program on Material Science and Nanotechnology, MSNT 2020. Our today's session being the last day of our FDP program. At this moment, I would like to express my heartfelt gratitude to our department and to our management, B.S. Abdur Rahman Crescent Institute of Science and Technology, for all their support in having us arrange this kind of a beneficial program. I extend my sincere thanks to the registrar and the deputy registrar of our institution for always motivating us to conduct these events. I also thank each and everyone who sincerely committed to this event to make it a success. Also, I would like to acknowledge and appreciate our enthusiastic, cooperative, and cheerful audience for their involvement and participation all throughout these 14 days. Thank you, one and all. Let's start our session with an inspiring quote of our people's president, Dr. APJ Abdul Kalam sir. Dr. APJ Abdul Kalam sir has stated that without your involvement, you cannot succeed, and with your involvement, you cannot fail. So let's make each day our masterpiece. Our speaker for today's session is Dr. R.Karvembu sir, Professor, Department of Chemistry, National Institute of Technology, Tiruchirappalli. His topic for today's session is Nanomaterials in Catalysis. Before the start, let me give a brief introduction about our speaker. Professor Dr. R.Karvembu sir has completed his bachelor's and master's from St. Joseph's College, Trichy. He obtained his MPhil and PhD degrees from Bharathiar University, Coimbatore. He worked as a postdoctoral scientist at Pohang University of Science and Technology, South Korea for 1 year. He was a visiting researcher at Vienna University of Technology, Austria. He also visited various universities like Sophia University in Japan, and Glasgow University in UK, and University of Rennes in France. He has received lot of fellowship and honors, including the CSR NET Fellowship, UK IERI Fellowship. He was awarded Sophia Lecturing Research Grant from Japan. He also got the Young Scientist Fast Track Project from DST India. He was a top-cited author for the year 2012 to 2013 in the Journal of Organometallic Chemistry elsewhere. His papers received top-cited paper accreditation for the year 2011 and 2012 from the Chemical Engineering Journal elsewhere. He has completed various sponsored projects as PI from DST, CSAR, BRNS, CHECIP, and as a co-PI, he has completed DST Nano Mission worth 5 crores, CSAR project worth 8.2 lakhs, and DRDO project worth 10 lakhs. He is currently working in the project sanctioned by the SERB. He is a member in professional bodies like Chemical Research Society of India, Indian Science Congress Association, Indian Chemical Society, Indian Council of Chemists, etc. He is the editorial member in journals like Inorganica Chimica Acta, Current Organocatalysis, Journal of Catalyst and Catalysis, etc. His research interests fall under coordination chemistry, organometallics, bioinorganic chemistry, and catalysis. He has guided around 11 PhD scholars, 3 postdocs, 40 MSc students, 1 MPhil student, and 1 MS student by research, and has co-guided 1 PhD scholar. He is currently guiding 11 PhD scholars and 1 postdoctoral student. He has published around 195 articles in high impact factor journals and has authored 2 book chapters. He has filed on patent and has presented papers in around 80 conferences. Now I welcome our speaker to heartily take part in our session. Thank you, sir. Please take over the session.
Good evening, everyone.
Good evening, sir.
Yeah. So I thank Ms. Aisha for introducing me. I thank Dr. Vasimalai and other faculty members of Chemistry Department of BS Abdur Rahman University for inviting me to give a lecture in this faculty development program. Yeah, just a minute. I want to. Yeah. This is the 14th day of 14-day faculty development program. This may be the most awaited lecture by many of you, not because of the fact that I give this lecture, but because of the fact that you will not have any more lecture after this. I have seen the list of speakers who have given talk in this faculty development program. All of them are eminent faculty members or scientists working in the field of material science or materials engineering. We have seen, I mean, during the course of this program, you must have seen different kind of materials for different applications. I'm basically an inorganic chemist trained in homogeneous catalysis. We have utilized the superior properties of nanomaterials in the field of catalysis. Now, this is a very interesting application of nanomaterials. And you will see, I mean, in the examples that I am going to show. Yeah. So I just would like to start from my introduction before tell you about some of the interesting catalytic systems involving nanomaterials. You know, the catalyst is a substance that speeds up a chemical reaction. The term catalyst or catalysis was coined first by the scientist Berzelius in the year 1835. It means that this is not a new field. This is a very old field in chemistry. But I should say that this is a very important field. When you go to any chemical industry, you can see a separate R&D division for developing catalysts for their own chemical processes. Because catalysts are directly related to the cost of the product or cost of the chemical that the particular company makes. If you develop a good catalyst, then the cost of the chemical that the particular company makes comes down drastically because the catalyst increases the productivity. Now, the interest or the importance of this field, catalysis, can be very well understood from the number of Nobel Prizes it has got. The first Nobel Prize to catalysis was given to Oswald in the year 1909. You all know that Nobel Prize is being given from 1901. The first chemistry Nobel laureate is Van Hoff. In 1909, the first Nobel Prize was given to the field of catalysis to Ostwald, who has investigated chemical equilibrium and also velocity of chemical reactions. Later in 1918, Haber received Nobel Prize for the process he has developed for the synthesis of ammonia. We all know that process is now called as Haber's process of synthesis of ammonia. This Haber's process has made revolution in industries. Not only in industries, this has made revolution in agriculture sector. Only after this Nobel Prize, the importance of catalysis has been felt by many scientists. Because before Haber's process, there was no process for the production of ammonia in bulk scale. Because at the time, ammonia is required in large quantities for the production of urea. You all know the application of urea in agriculture. So urea could not be manufactured in bulk quantities because of the unavailability of ammonia at the time. Only after the Haber's process, industries were able to produce ammonia in large quantities, which were utilized subsequently for the production of urea. So this process has made revolution in chemical industries as well as in agriculture sector. And between 1918 and 2000, there were many Nobel Prizes to catalysis. You might be knowing. I skipped all those Nobel Prizes. And later in 2001, Knowles, Nairi, and Shortplus shared Nobel Prize for the development of various catalytic asymmetric processes. Knowles and Nairi, they have developed catalytic asymmetric reduction processes by using rhodium and ruthenium chiral catalysts. Shortplus has developed the asymmetric epoxidation of allylic alcohols. Then in 2005, Grubbs, Schrock, and Chauvin, they shared Nobel Prize for the development of a very efficient olefin metathesis process by using different, the carbene catalysts. And as I said, there were many Nobel Prizes in between, 1918 and 2001. Even after 2001, there are some Nobel Prizes to catalysis. Just to show the importance of this field, I've listed very few Nobel Prizes. And then about 90% of the chemicals made in industries, they use catalytic processes. Almost all of the chemicals that we use today, it may be a fine chemicals or cosmetics or fragrances or pharmaceutical or the drug molecules, whatever. Most of these chemicals are made by means of catalytic processes. It means by using some catalysts. And how catalyst increases the velocity of a chemical reaction. In presence of the catalyst, reaction follows a different path for which the energy required is less. You just look at this picture. There is a boy and a girl. The destination of both of them is this point, this flag. They want to reach this point. This boy, he's climbing the mountain, and then hopefully he will reach this point. For this, definitely he would require high energy, right? Because he has to climb the mountain. But this girl, she's very smart because she's carrying a catalyst. She follows a different path. She follows this tunnel to reach her destination. And definitely, she would require very less energy compared to the energy required by this boy to reach the destination, right? So this girl prefers a less energy path to reach the destination. Similarly, in presence of the catalyst, the reaction proceeds via a different path for which the energy required is very, very less, so that the reaction proceeds at a faster rate. Most of the catalytic processes, they proceed under industrially feasible conditions of pressure and temperature. It is not only the catalyst increases the rate of the reaction, and catalyst also make the reactions to proceed under industrially feasible conditions of pressure and temperature. That's why, as I said, any chemical industry, they have a separate R&D division for the development of their own catalyst for their chemical processes. In general, catalysis is classified into two broad categories. One is homogeneous catalysis, other one is heterogeneous catalysis. We cannot say this is more advantage than that one. One has more advantages over the other one. Each one has its own advantages and disadvantages. It depends. Particularly, the advantages of homogeneous catalysis is that it has high activity and selectivity. Homogeneous catalysts are highly active and selective. What do you mean by active? I mean, it accelerates the rate very fast. The rate of the reaction will become very fast in presence of the homogeneous catalyst. So it's highly active. What do you mean by highly selective? In a simple way, you can explain that in a chemical process, more than one product is possible, 2, 3, or 4. But in presence of the catalyst, only one product is preferentially formed. That is the selectivity, in simple terms, right? So homogeneous catalysts are selective as well as reactive. But at the same time, since the homogeneous catalyst is in the same phase of the reactant, right? So you cannot separate the catalyst after the reaction very easily. You have to adopt some sophisticated processes like chromatography. But you can adopt these techniques in laboratory scale, but in industrial scale, it is very costly technique, right? Because of this cumbersome product purification or cumbersome processes involved in the separation of catalyst, many efficient homogeneous systems cannot be commercialized, cannot be industrialized. Coming to this heterogeneous catalysis, since the heterogeneous catalyst is insoluble in the reaction medium, and in most of the cases, the catalyst and the reactants are in different phase, at the end of the reaction, you can easily separate the catalyst by means of simple filtration or centrifugation. So that's a very big advantage because the separation process is very simple and less cost is involved. So many industries prefer heterogeneous catalysts, though they possess less activity compared to homogeneous catalysts. What are the disadvantages of heterogeneous catalysis? They possess less activity and less selectivity. The points which are advantageous in the case of homogeneous, no, that become disadvantages in the heterogeneous. Now, the point that is disadvantage in the homogeneous, that has become advantage in the heterogeneous catalysis. So homogeneous catalysts are very active and very selective. At the same time, heterogeneous catalysts can be separated easily from the reaction mixture after the reaction. Now, we require a catalytic system in which the catalyst should be active and selective like homogeneous. At the same time, the catalyst should be recovered after the reaction very easily like heterogeneous. It means the scientists are working to combine the advantages of both homogeneous and heterogeneous catalysis. Now, at this point of time, nanocatalysis has come into the picture. So the nanocatalysis is a bridge between homogeneous and heterogeneous catalysis. You know the example for homogeneous catalysis, for example, Wilkinson catalysis, the rhodium complex is a homogeneous catalyst. You also know the example for heterogeneous catalysis, like the Haber's process, where the metal is the catalyst, right? That is in the different phase. So Haber's process is heterogeneous catalysis. Ziegler-Natta polymerization process is heterogeneous catalysis. But this nanocatalysis, now this is the new terminology compared to the previous broad classifications. Whenever you use nanomaterial as a catalyst, then the process is called as nanocatalysis. Very simple. And this nanocatalysis, as I told you, this acts as a bridge between homogeneous and heterogeneous catalysis. How? Because of the nano size, you have large surface area when nanomaterials are used as catalyst in a reaction. When you divide the bigger particle into smaller particles, the inner surface becomes the outer surface and surface area becomes larger. So when surface area is more, then there is a close contact between the catalyst, that is the nanomaterials, and the reactants. So this close contact is very similar to homogeneous system. Why homogeneous catalysts are very active? Because the homogeneous catalyst is in the same phase of the reactants. For example, you take a solvent, you add the reactants are soluble in that particular solvent. Maybe A and B are the reactants. Now you add a catalyst to the reaction medium. The catalyst is also soluble. Now the reactants as well as catalyst all are in the solution phase or solution state, since all are soluble in that particular solvent. Because of that, since the reactants and catalyst are in the same phase, there's a close interaction between the catalyst and the reactant. Similarly here, because of the high surface area, right, there is a good interaction between the catalyst and the reactants when nanomaterials are employed as catalyst. And most of the nanomaterials, particularly the inorganic nanomaterials or metal-based nanomaterials, they are insoluble in most of the solvents that are employed in catalysis. So because of that, these nanomaterials are insoluble in the reaction medium. It means they are in a different phase compared to the reactants. Let us assume that reactants are soluble in the medium and nanomaterials are insoluble in the medium. So because of the insolubility of these nanomaterials, and this can be easily separated after the reaction by means of simple, the filtration or centrifugation or any kind of a simple technique. So nanomaterials combine the advantages of both homogeneous and heterogeneous system. Nanocatalysts are active like homogeneous system, and this catalyst can easily be separated from the reaction medium like heterogeneous system. So with this background, with this motivation, we wanted to develop some nanocatalytic systems for industrially important organic transformations. For this purpose, we have initially prepared a very simple nanoparticle, copper oxide. This is not the new nanoparticle, or this is not the new method for the preparation of copper oxide. This is a well-known method for the preparation of copper oxide nanoparticle. You have, the thousands and thousands of literatures for the preparation of copper oxide nanoparticles with different morphologies, with different particle size. But we have selected this quick precipitation method. Copper oxide is prepared from a copper acetate by means of a simple process, right? And we have employed this copper oxide nanoparticles as catalyst for N-arylation of benzimidazole, right? Why we have selected this organic transformation to study the catalytic activity of copper oxide? When we have looked at the literature, this N-arylation is very important because many of the commercially available drug molecules or many of the commercially available OLED molecules, they contain N-arylated benzimidazole moiety. For example, you look at the first structure, right? This is an antiviral molecule. This contains N-arylated benzimidazole moiety. This is an OLED molecule, a very important OLED molecule. This also contains N-arylated benzimidazole moiety. You look at here, this is a commercially available drug for hypertension. This is telmisartan. This also contains N-substituted benzimidazole moiety. So there is a need for the efficient N-arylation process of heterocycles, particularly benzimidazoles, right? So we have utilized these copper oxide nanoparticles as catalyst for N-arylation of benzimidazole. After the preparation of copper oxide nanoparticles, though they are prepared by means of the known method, and it's a well-known nanoparticle, we have characterized the material we have got just to confirm that we have got the correct copper oxide nanoparticles. And the crystallite size of copper oxide that we have prepared was found to be 8 nanometer, and XRD pattern matches with the JCPDS data. TEM images showed that the copper oxide nanoparticles are highly dispersed and they are spherical in nature. Bed surface area of copper oxide nanoparticles was found to be 81 meters square per gram, and this copper oxide nanoparticle is highly stable. It means that, and of course, we did not do reaction at this temperature, but this thermal stability indicates that these kind of nanoparticles can be used as a catalyst in a reaction that employs of even very high temperature. Even at 900 degrees centigrade, this catalyst remains in the original form. It means that this can catalyze the reaction even at high temperature when it is required. You look at this reaction. This is a very simple N-arylation of benzimidazole. This is a benzimidazole, and this is the coupling partner is aryl halide. This may be aryl bromide, chloride, or fluoride, containing different substituents like electron withdrawing or electron releasing group. By using copper oxide nanoparticles, we have performed this reaction very efficiently. During the development of a new catalytic system, initially how to optimize the reaction parameters: reaction time, solvent, base, amount of base, catalyst amount, temperature, and so on. We have also optimized the reaction conditions. If you look at this N-arylation of benzimidazole, gave good yield after 24 hours. Till 24 hours, the yield of the product increases, after which there is no much increase in the yield of the product. It means 24 hours is the optimized time, but it depends, right? When you change the substrate, it depends. We have employed different bases. Potassium carbonate was found to be the efficient base. 2 millimole of potassium carbonate was required for the efficient N-arylation process. Different solvents like dimethyl formamide, dimethyl acetamide, THF, and DMSO were tested dimethyl acetamide was found to be the suitable solvent. Of course, various, if you look at the literature, various CN coupling reactions proceed efficiently in DMSC solvent. Similarly, in our case also, DMSC was found to be the best solvent. And 120 degrees centigrade is required for efficient relation of benzimidazole. 10 mole percentage of catalyst is required. Even the less than or higher than 10 mole percentage did not give the good yield of NR-related benzimidazole. Under the optimized conditions, the scope of the reaction is extended. It means that we have used different aryl halides. I told you we have used aryl fluoride, aryl bromide, aryl chloride with different substituents in different positions. The substituent in the para position, substituent in the ortho position, cyanide substituent, ketone substituent. You can see here the isolated yield of the product is moderate to good in almost all the cases. You see, different substituents were tried. It means that the catalyst is compatible. Whatever aryl halide you use, you can carry out the N-arylation process, and you can prepare different derivatives of N-related benzimidazole. Importantly, you can see here, even the heterocyclic aryl halides can be used as coupling partner in this reaction. And using heterocyclic aryl halides is very difficult in homogeneous system, because in the heterocyclic compound, we have the donor atoms like nitrogen, sulfur, oxygen. So these donor atoms will form a coordinate bond with the metal, which subsequently deactivate the catalyst, right? So the catalyst will lose its activity. So catalysis, the process will not proceed further when you use heterocyclic aryl halides in homogeneous. But here, in this nanocatalysis process, even though the catalyst is active like homogeneous catalyst because of its good interaction with the substrates, at the same time, even the heterocyclic aryl halides can be used to form the very good derivatives of benzimidazole, because as you know, most of the drug molecules are heterocyclic compounds. And here I have shown that by using various aryl halides, the benzimidazole molecules can be unrelated to form different derivatives of benzimidazole. Just to check whether it is applicable, whether copper oxide can be used as a catalyst only for the N-relation of benzimidazole, or it can also be used as a catalyst for the N-relation of other heterocyclic compounds. We have performed the N-relation of imidazole, carbazole, pyrrole, and indole. You can see that in all the cases, the yield is very good. We were able to isolate the product in good form. And of course, all these products were characterized by means of NMR and mass. You could find in the paper I have mentioned in the supplementary material, right? So copper oxide is not only a catalyst for the N-relation of benzimidazole. And this is a very general catalyst. This copper oxide can be used as a catalyst for N-relation of any heterocyclic compound containing NH moiety by using any aryl halide. So it is very interesting catalytic system. Now, just to show the importance of nanoparticles in catalysis. This is the copper oxide. That I have shown now. The particle size is 8 nanometer. This is the surface area we have employed in the N-relation process. The isolated yield is 86% in this case. But now, when you employ the bulk copper oxide, you see the particle size is 340 nanometer. And of course, when the particle size is higher and surface area will come down, it's only 18 nanometer. When you use this copper oxide as a catalyst for the same reaction, you see the yield of the product is drastically reduced. It indicates that the nanoparticles or the nano copper oxide efficiently catalyze the reaction compared to bulk copper oxide, right? So that indicates the importance of nanomaterials in catalysis, or the efficiency of nanomaterials in catalysis. Now, I told you, this is active like homogeneous. We should also separate the catalyst at the end of the reaction very easily by means of simple filtration or centrifugation. We were able to do that. And we have used the recovered copper oxide as catalyst again in the second cycle. Now again, after the reaction, it was separated. Again, we have used in the third reaction again, and we have done for many times, but I have shown here only 4 times. You see here, the catalyst can be recovered very easily and can be again reused for many cycles without loss in the activity. You see here, the yield in all these cases is around 90%. There's no loss in the activity, even if you reuse the catalyst, right? So the copper oxide is active like homogeneous here, and also like heterogeneous, the catalyst can be easily separated and reused for many cycles. The proposed mechanism is that both the aryl halide and heterocyclic compound, they get adsorbed on the surface of the copper oxide. They interact with each other. That leads to the formation of the product. After establishing the application of copper oxide nanoparticles in the N-arylation of benzimidazole, or even in the case of N-arylation of any heterocyclic compound, we have utilized the same copper oxide nanoparticles in another important reaction. This is a Ullmann type coupling reaction, right? It's a coupling between phenol or thiophenol with aryl halide to form diaryl ether or diaryl thiether. When you couple aryl halide with phenol, you will end up with diaryl ether. When aryl halide is coupled with thiophenol, then we will get diaryl thiether. This is a Ullmann type coupling reaction, right? In a classical Ullmann reaction, the copper metal is used as a catalyst. Here, we have used copper oxide and nanoparticles. And now again, question arises, why we have to develop catalyst for these reactions? When you look at, these two are the naturally available compound, is obtained from the plants. And these two are pharmaceutically important. So these two pharmaceutically important natural products, they contain diaryl ether structure. And you see, this is a structure of thyroxine, a hormone secreted in the thyroid gland, that contains diaryl ether structure. And this is the drug molecule for the lung cancer. This contains diaryl thioether structure. So there is a need for the development of catalyst for the preparation of diaryl ether and diaryl thioether. So with this motivation, we have used the same copper oxide nanoparticles as catalyst for the production of diaryl ether and diaryl thioether. Interestingly, when we have reported, these processes, this was the first Ullmann type coupling at room temperature. I told you in the beginning that in presence of the catalyst, the reaction proceeds under industrially feasible temperature, right? So here, the catalyst not only increases the velocity of the reaction, and here in presence of the catalyst, the reaction proceeds under very mild condition. Just at room temperature, the coupling happens and diaryl ether and diaryl thiether, these were formed. And the reaction, as I told you, in the previous system, the reaction conditions were optimized, the time of the reaction, solvent, base, amount of base, and under the optimized conditions, the scope of the reaction or the scope of the catalytic system is extended, right? We have used different aryl halides, or different aryl halides were coupled with phenol to form different derivatives of diaryl ether in very good yields, right? In few cases, we have obtained around 90% of the yield. And even the derivatives of phenol can be used. This can be coupled with aryl halide to form. You have substitution on both sides of the aryl moiety. On both the aryl rings, we have the substituents in this diaryl ether. The reaction proceeded very well. So you may have the substituents in the para position or in the ortho position, maybe the phenol as well as in the aryl halide. Now, if you have substituent in the ortho position, of course, there is a decrease in the yield because of the steric effect. Otherwise, you can see a very good yield of diaryl ether. So it means the copper oxide is very active like homogeneous catalyst in the case of Ullmann type coupling to form diaryl ether molecule. Similarly, we have extended the scope to prepare different derivatives of diaryl thiaethers, right? And here also you can employ the heterocyclic bromides as coupling partner to form diaryl ether. The X may be oxygen or the X may be S in the case of diaryl thiaether. And the one of the aryl moiety is the heterocyclic ring, right? In the in the initial slides, I have shown some of the diaryl ethers or diaryl thiaethers which have importance in the field of pharmaceuticals. They contain heterocyclic moiety. So you should be able to use the heterocyclic coupling partner to prepare the pharmaceutically important compounds. And we have demonstrated here the copper oxide nanoparticles can be used as a catalyst for the coupling between phenol or thiphenol with 2-bromopyridine to form the diaryl ether or thiaether containing heterocyclic aryl moiety. Again, the 2-bromopyrimidine can also be used as a coupling partner to form a very important diaryl ether or diaryl thiaether compounds. And I told you that homogeneous catalysts are active and selective. And we have seen here the copper oxide nanoparticles are active like homogeneous because of its close interaction with the substrates. And in order to demonstrate that these nanoparticles are also selective like homogeneous catalysts, we have performed some reactions. You just look at here. This is a coupling between phenol and this dihalobenzene. Now there are two possibilities. There's elimination of HBr or elimination of HCl. So there are two possible products, but among these products, only this product is formed in 100% selectivity, right? So it shows that these nanoparticles may be heterogeneous because they are insoluble, but they are active and selective like homogeneous catalysts. Similarly here, we have taken equal amount of phenol and thiphenol in a single reaction, right? So maybe this aryl halide, just to see whether it prefers phenol or thiphenol. Anyway, two products are possible. When this is coupled with phenol, you will get diaryl ether. When this is coupled with thiphenol, you will get diaryl thiaether. So among the two possible products, diaryl thiaether is formed preferentially. 92% yield of diaryl thiaether was obtained. It means the reaction is highly selective. If you get equal amount, then it's not selective. But you see, one of the products is highly formed, preferentially formed over the other in these reactions. That demonstrates the selectivity of nanoparticles when you employ them as a catalyst in chemical transformation. Again, these nanoparticles can be separated after the reaction and can be recycled for many cycles. The mechanism is very similar to the previous case. Then after establishing copper oxide catalytic system for two important organic transformations, again, we moved on to another copper-based catalyst, that is copper on the surface of boehmite, that is aluminum oxyhydroxide. Again, this material is already reported. The source for copper is simple copper 2 chloride, and we have used pluronic P123, a triblock copolymer, as a surfactant. And the source for aluminum oxyhydroxide is aluminum trisecondary butoxide, and aluminum oxyhydroxide or boehmite is a support, and over this copper, metallic copper is impregnated, right? And this copper on boehmite, I just show the characterization and then I go to the importance. And you just see here, there is a formation of copper cluster on the surface of the boehmite, and the amount of copper is found to be 3.21 weight percentage. And just to see that there is only a metallic copper, or also we have copper oxide on the surface of boehmite, we have performed XPS analysis, and you can see here, in addition to metallic copper, a trace amount of copper 1 and copper 2 oxides were also present. And it is obvious that you have a copper when it is exposed, it will immediately form copper oxide. So the stability is not very excellent, At the same time, the stability is enough to carry out the reactions, right? And if you want to keep the catalyst for a long time, you have to store in the inert atmosphere, right? And now this copper and bohemite was employed as catalyst in a very simple organic transformation, that is oxidation of alcohol to corresponding carbonyl compound. It means the oxidation of primary alcohol to aldehyde, oxidation of secondary alcohol to a ketone, right? It's a very simple organic transformation. But if you look at the target synthesis of any drug molecule or any other molecule, now target synthesis, the synthesis involves maybe 20 steps or 30 steps. At least one or two steps in any target synthesis involves selective oxidation of alcohols to carbonyl compounds. So there is a need for the development of catalyst for the selective oxidation of alcohols, and we have employed this copper and bohemite as a catalyst for this oxidation process. Again, as usual, we have optimized the conditions. Different solvents were tried. Water was found to be a good solvent for this reaction. It's good. If you do the reaction in water, it is considered as a green reaction. And the mole ratios or the amount of different species, base, catalyst, oxidant, they were all optimized. And you see, we have tried the reaction with different oxidants, hydrogen peroxide, tertiary butyl hydroperoxide, NMO, and pyridic acid. Since the pyridic acid is highly soluble in water, pyridic acid has given a very good yield of the carbonyl compound when alcohols are oxidized. Then under the optimized conditions, the various alcohols are oxidized. You see, benzylic alcohols are oxidized to corresponding carbonyl compounds in very, very good yields. Now, almost you see in few cases, the quantitative transformation, all the alcohol molecules are converted into corresponding carbonyl compounds. You see, these yields are GC yields, and in few cases, in parentheses, isolated yields are given. So whenever we have isolated the products were characterized by NMR, mass, and other techniques, right? Very importantly, you see here, I told you the selective oxidation, right? If you look at here, the oxidation of cinnamoyl alcohol to cinnamaldehyde, very important transformation. There are two possibilities, oxidation of alcohols as well as oxidation of this double bond to epoxide. But if you look at, in this case, only the alcohol is oxidized. Now the double bond is unaltered during the course of the reaction. That is the selectivity, right? So the cinnamaldehyde is obtained in a moderate yield, not very good, but the selectivity is good. The selectivity is 73%. But here in this case, even the selectivity is 100%. It means only alcohol is oxidized. In this case, of course, the trace amount of epoxide is also observed, but here only the alcohol is oxidized, the double bond is not at all oxidized, so selectivity is 100%. So again, it is demonstrated that the nanocatalysts are selective and also active, and you see here the 95% of this ketone is formed from this alcohol, right? And some of the alicyclic alcohols were also tested. Here the yield is very less because this is sterically hindered substrate, and of course whatever catalyst you use, and this conversion is always less efficient. And again, to establish the selectivity of the system, we have taken the equal amount of primary alcohol and secondary alcohol. We have seen which alcohol is preferentially oxidized in presence of this copper and bohemite catalyst. If you look at the product, the oxidation of benzyl alcohol into benzaldehyde happens predominantly in presence of this catalyst, right? So we have obtained 83% of this benzaldehyde. Only 13% of this acetophenone was formed from this 1-phenylethanol. It means if we have the primary and secondary alcoholic group in a substrate, this catalyst prefer to oxidize the primary alcoholic group to corresponding carbonyl compound. So that is the selectivity, right? In a single substrate, if you have two different carbonyl groups, when you add this catalyst, this will oxidize only the primary alcohol, whereas secondary oxidation of secondary alcohol is very meager. right? So this again demonstrates the selectivity of the nanocatalyst. And again, the catalyst can be recovered, reused. This is the heterogeneity test. Whenever you have the solid support over which you have the catalytically active metal center, during the reaction in the solvent, there is a possibility of leaching of the metal from the support, and then the metal in the solution catalyze the reaction homogeneously to see whether it is truly heterogeneous or is there any leaching of metal and catalyze the reaction in a solution state. No, we have done the reaction, for example, for 1 hour. At 1 hour, the yield of the product is 60%. After 1 hour, the catalyst was filtered from the reaction medium, and the reaction is continued without the catalyst. So once the catalyst is removed, you see there is no improvement in the yield of the product. It means there is no metal in the solution, which indicates there is no leaching of copper from the surface of the bohemite. So the reaction here is truly heterogeneous in nature. At the same time, we have very good selectivity. And of course, the reaction proceeds via the formation of copper oxo species. And we have detected the presence of copper oxo species in the reaction medium by means of U visible and FTIR techniques during the reaction. Right. Now, I've explained you the application of copper oxide nanoparticles in 2 different reactions as catalysts. That is the versatility. You have a catalyst. If you can employ in a different reactions, that's good, right? That's the versatility. If you can use it as a catalyst for only one particular reaction, then for every reaction you perform in the industry, you require a different catalyst. But if the catalyst is versatile, it can catalyze many reactions, then it's good. And again, this copper on bohemite, I have shown that it could catalyze the oxidation of alcohols. And not only that, we have, again, to see the versatility, we have employed this as a catalyst in the formation of ketoenamine from beta-diketone and amines. Again, at room temperature, this copper on bohemite could catalyze the formation of beta-ketoenamine from beta-diketone from different amines, right? Again, this beta-ketoenamine is very important molecule, mainly because if there is a chiral axillary here, this can be used as a chiral ligand to perform many asymmetric reactions. So in that way, there is a need to prepare the beta-ketamines very efficiently. So we have used this as a catalyst, copper on bohemite as a catalyst to prepare beta-ketoenamines. And the reaction conditions were optimized. 10 milligram of the catalyst was required to proceed or to perform the reaction efficiently. And the different copper loading were tested. When the copper loading was 3.2%, the reaction was efficient. And of course, as usual, we have extended the scope to see the generality of the system. Now, different beta-diketones were employed. Different amines were employed. Aromatic amine, alicyclic amine, even the aliphatic amine was employed. You see, different aliphatic amines were combined with beta-diketones to form beta-ketoenamines in very good yields. You see, 99% within 5 minutes, this product was formed. So it's a very efficient catalytic system to prepare beta-ketoenamines, right? And again, we have proved that the reaction is truly heterogeneous. There's no leaching of copper. Of course, there is a slight reduction in the yield when the catalyst is further used. Maybe the copper becomes copper oxide during the course of the reaction. That might be the reason. And we have studied the mechanism of this reaction by means of DFT calculations. You see, this is the energy profile of uncatalyzed reaction without copper on bohemite. This is with catalyst. Without catalyst, you see, the energy of the transition state is 49.1 kilocalorie per mole. But if we add a catalyst, the energy of the transition state comes down. That's why I said in presence of the catalyst, the reaction proceeds through the pathway for which the energy requirement is less. So in presence of the catalyst, the energy required is less to form the transition states. This is without the catalyst, it requires high energy. With catalyst, it requires less energy. Now, this copper cluster can interact with this ketone oxygen or this enol oxygen. There are two possibilities. We have calculated both the possibilities here. When the cluster interacts with the carbonyl oxygen, the energy of this transition state is 33 kilocalorie per mole. When the copper cluster interacts with enol oxygen, the energy of the transition state is slightly higher. It means this interaction may not be preferred, and this is the preferred interaction. The copper cluster interacts with carbonyl oxygen, and all the transition states are optimized. And this is the proposed mechanism for the formation of beta-ketone catalyzed by copper on boehmite. Initially, beta-diketone gets enolized to form enol, right? And then this copper cluster interacts with this carbonyl oxygen, and then this amine is added between these carbons, and subsequently there is elimination of water that finally gives beta-ketoenamine product. So we have shown that copper oxide is a very good catalyst. Copper on boehmite is also a very good catalyst, right? And further, we have developed copper oxide on aluminosilicate as a catalyst. We have employed this copper oxide on aluminosilicate as a catalyst for the coupling of styrene with aryl halide. This is a Hague coupling reaction. We were able to prepare many stilbene derivatives. And by using the same catalyst, whenever we use nanoparticles as a catalyst, we wanted to try with different reactions just to show the versatility, right? And similarly here, the same copper oxide on aluminosilicate, we have employed it as a catalyst for the alpha arylation of beta diketone, right? And we have developed many copper-based nanocatalytic systems, and we have got very good results. Then, motivated by these, we wanted to perform some ruthenium-based nanocatalytic systems. I will take another 5 to 10 minutes to wind up my lecture. I told you that basically I'm trained in homogeneous catalysis. I have much interest in ruthenium chemistry. I wanted to prepare some ruthenium nanoparticles as catalyst, right? We have prepared ruthenium nanorods on the ruthenium oxide nanorods actually on the surface of graphene nanoplatelets. Initially graphene nanoplatelet is functionalized, and then tris acetyl acetonato ruthenium. This is a source for the ruthenium, and when it is added, now the very excellent ruthenium oxide nanorods were formed on the surface of graphene nanoplatelets, right? And if you look at the width of these nanorods is only 5 nanometer. And these ruthenium oxide nanorods on the surface of graphene nanoplatelets were employed as catalyst for transfer hydrogenation reaction. This is the transfer hydrogenation reaction. You forget the catalyst, you see the reaction. This is very similar to MPV reduction or open air oxidation. There is a transfer of hydrogen from this alcohol to ketone. So ketone gets reduced to alcohol. This alcohol gets oxidized to a ketone. There's a transfer of hydrogen from one substrate to other substrate. So this is called a transfer hydrogenation reaction. What is the interesting thing here? If you don't have ruthenium, there won't be any transfer of hydrogen from alcohol to ketone. So you need a mediator. The mediator is ruthenium. Ruthenium takes hydrogen from alcohol and gives hydrogen to the ketone, right? So you require a catalyst for this transfer hydrogenation process. And this hydrogenation process is preferred compared to classical hydrogenation using hydrogen gas. Because when you use a hydrogen gas for hydrogenation, you need to be very careful, because maintaining hydrogen gas pressure is not so easy. But here you can perform hydrogenation very easily, because you don't require to maintain the pressure of any reagent in this case. By means of this, now this alcohol is taken in excess. because if you don't take this in excess, this is the reactant as well as solvent. This is not in stoichiometric amount. This is in excess. But if you don't take this in excess, the reverse reaction is possible, because once this is formed, then again this hydrogen is transferred to here, then these two will form. So reverse reaction is very much possible. But since this alcohol is taken in excess, the reverse reaction is avoided. So we have taken different ketones, and different alcohols were obtained from the reduction of the ketone. You see here, the benzylic alcohols were obtained, right? The aliphatic alcohols were prepared, alicyclic alcohols were prepared, heterocyclic alcohols were prepared. So the reaction is very gentle. So these ruthenium nanorods on the surface of graphene nanoplatelet could catalyze the reduction of ketones to form different kinds of alcohols by means of transfer hydrogenation strategy. Now you see, to know the leaching of ruthenium from the surface of graphene nanoplatelet, you see here, after 4 hours, the yield of the reaction is around 50%. After 4 hours, the catalyst was separated. The reaction was continued without the catalyst. There is no increase in the yield of the product, which indicates that the ruthenium, which is present on the surface of the support, only catalyzed the reaction. There was no leaching. But when we have analyzed the solution after the separation of the catalyst by ICP, the solution contains a very, very less amount of ruthenium. It means that there is a very, very, very insignificant leaching, but that was not sufficient to catalyze in solution state, right? So here you see that there is a slight reduction in the yield when you use the catalyst at the 4th run, but this can be increased by the calcination of the catalyst. This is without any process. If you employ as such, there's a slight reduction because of the absorption of some other reactant solvent molecules on the support, on the solid support, right? And this is another ruthenium-based catalytic system. This is metallic ruthenium on the surface of graphene nanosheet. You see very, very minute ruthenium particles. The size of the ruthenium nanoparticles is about 0.5 to 3 nanometer, right? So we have used these nanoparticles as catalyst for the oxidation of alcohols to corresponding carbonyl compound. I told you the importance of this reaction already. And again, the previous oxidation reaction, we have employed copper catalyst for the same reaction, but where the periodic acid was required as an oxidant. But here, you look at this reaction, there's no oxidant, right? You have catalyst, you have solvent, temperature, only time. What is the oxidant here? The oxidant is air. Now you perform the reaction in air atmosphere. So the oxygen present in the air can act as an oxidant and catalyze the oxidation of alcohol in the presence of ruthenium nanoparticle. Very interesting. And we have obtained different carbonyl compounds. Even we could oxidize the aliphatic alcohol to carbonyl compound. The oxidation of aliphatic substrates is very difficult, right? But this could catalyze very efficiently. Even there is selectivity. This ruthenium-based nanosystem also catalyze preferentially oxidation of primary alcohol compared to oxidation of secondary alcohol. That has been established in the aromatic system as well as in the aliphatic system, right? After the reaction, and there is a slight increase in the particle size. Once we use the reaction again and again, right, the particle size is slightly increasing. And still, even 1 to 4 nanometer is a very, very small size. But still, the reaction is very good even when you reuse the catalyst. And now the thing is, first we have used the catalyst for the oxidation of alcohol. Then the catalyst is recovered at the end of the reaction, and it is calcinated, is calcined to form again ruthenium oxide nanorods. You see, very interesting. Now the ruthenium oxide nanoparticles, after the reaction, it was recovered. Again, this calcined to form ruthenium oxide nanorods. And again, we have employed these nanorods for the transfer hydrogenation reaction, because already we have established the application of ruthenium oxide nanorods in transfer hydrogenation. That's the versatility the tunability of the ruthenium nanomaterials in these systems. And with this, I would like to conclude my lecture. The ruthenium, the nanoparticles, particularly copper-based, they are cheap, are stable, efficient. We have seen, no? I have shown that in many cases, you can reuse the catalyst for many cycles. They're heterogeneous in nature. It means you can easily isolate the catalyst, or you can easily isolate the product in pure form by means of the simple physical processes. And the catalytic process is simple, ligand-free. In the case of organometallic catalysis, first you have to prepare ligand and you have to, again, prepare organometallic compound. So it's a ligand-free process. So it is a simple process and this is very efficient. Like homogeneous system, you have seen that we have obtained a very good yield of the product and it is operationally simple, safe. You don't require any sophisticated technique to carry out the catalytic processes. It would be, my lecture would be incomplete if I don't acknowledge these important persons, particularly for this lecture. I would like to thank DST Nanomission for funding. Only with this funding, we were able to develop these catalytic systems. And I would like to thank Dr. Iksu Kim, Shinsu University, Japan, particularly his help in the ruthenium-based, in developing ruthenium-based catalytic systems. Dr. Ganesh Babu, my PhD student, who is currently in IIT University, he has developed most of the copper-based catalytic systems, and he has also involved in the ruthenium systems. Dr. Kobi Rahman is actually a graduate student of Professor Kim in Shinsu University, and along with Kim, he has also helped us in developing ruthenium-based systems. Last but not least, I would like to thank my institute for providing all facilities and space to carry out these research works that I have presented to you today. Once again, I thank Dr. Vasimalai and other organizers for inviting me to give this lecture. I thank all the participants for your patient hearing. Thank you very much.
Thanks a lot for your excellent presentation, Professor. After a long time, I had a chance to listen your talk again. It's a very excellent talk. Thank you so much for your kind acceptance of our invitation during this pandemic period. Now I open the question session. Those who are in a Zoom link, dear participants, please unmute your mic and talk directly with our chief guest.
Yeah, you can ask me any kind of question from the presentation yes, I have made. Yeah.
Give an option to unmute by themselves, Harishankar. Yeah. And raise, check anybody is raising the hand. Please help them to unmute mic. Anybody?
If anybody has asked a question in chat box, you can yes, ask me, Vasimali.
Yeah, yes, Professor. We have received several questions from Zoom link chatting box as well as YouTube chatting box. I can go one by one. Yeah. So the first question was asked by Anupama. That madam asked how to identify the existing functional groups on nanoparticles.
That is based on the spectroscopic techniques, like how we identify the functional groups in the case of organic molecules. Similarly, based on the simple IR spectroscopy and also by means of XPS, whether we have the corresponding binding energies. By means of this spectroscopic techniques, also by using Rahman, we can identify the functional groups present on the any kind of the material.
Thank you, Professor. Then another one question was asked by YouTube chatting box from Dr. Srinada Sharma. Surface area of catalyst, it depends on the oxidation state of metal because metals exhibit various oxidation states.
Yeah, definitely. Particular transition metals, they exhibit various oxidation states. That's why we use transition metals in catalysis mostly. But the particle size mainly depends on the method you adopt for the preparation. So the conditions you adopt, the pH. Now I have shown the copper oxide nanoparticles. I have shown the sodium hydroxide over the arrow. So the addition of sodium hydroxide is very important while if you want to get a very small particle size, if you just add the sodium hydroxide, you will get only the bulk copper oxide. So only really the reaction conditions, pH, and the method you adopt for the preparation of particular nanoparticles, those will decide the particle size.
Okay, thank you, Professor. Now again, I am giving a chance to the Zoom link participants.
Yeah.
Please unmute your mic and talk with our chief guest. Anybody? Okay, if not, again, I can go for the charting box question, Professor.
Yeah.
Somebody is talking, please. Hello. Okay, Professor. Then this is from our research scholar, Aisha Begum, Department of Chemistry, our university.
Yeah.
Sir, can you explain about the reusability of copper oxide nanoparticles after the reaction? Until how many cycles we can able to use again these copper oxide nanoparticles?
Yes. No, it depends actually. You have specifically asked copper oxide, but I generalized the question. I mean, we normally do 10 cycles. Now, whenever the reviewer normally expect 10 cycles of reusability for any heterogeneous catalytic systems, right? In the case of simple copper oxide, or in the case of any simple metal oxide nanoparticles or metal nanoparticles, normally they exhibit very good recyclability, unless, I mean, they change its oxidation state or whatever it is. But whenever you have some support, like, I have shown copper on bohemite, ruthenium on graphene nanosheet. Whenever you have a support, many times you cannot directly reuse the catalyst. Since we have the support, some of the reactant molecules, they get absorbed on the support, or some of the solvent molecules, they get absorbed on the support. So that will provide some hindrance for the interaction between the active metal center and the substrate. In those cases, we have to again activate the catalyst. Maybe you can heat the catalyst so that these whatever molecules which are absorbed on the surface of the support, they go away from the material, and again you will have a lot of space for the reactants to interact with the active site. So whenever there is a support for the metal nanoparticles, and you require some process before you reuse it. And whenever you have a simple metal oxide or metal nanoparticle without the support, mostly they exhibit good recyclability without any further process.
Thank you, Professor. Zoom link participants, please unmute your mic and talk with our chief guest. Anybody? So Venkat, Abhilash, please give the option to unmute by themselves.
Already given, sir. Already given, sir.
Okay. Dear participants, you can able to unmute by yourself.
Yes,
So
sir.
you only Zoom link participants only having this chance, because you are only can able to ask directly to our chief guest, but YouTube participants not able to ask. Kindly utilize this opportunity.
Hello, sir.
Yes, please,
Hello.
sir.
Yes,
Yes.
sir. I'm Dr. P. Krishnamurthy. Sir,
Yeah.
my small question is it possible to synthesize ruthenium nanoparticle in ordinary laboratory conditions, sir?
Of course, it is possible. We did not adopt any sophisticated techniques. Only particularly to prepare ruthenium oxide nanorod or nanoparticle, you can follow the very normal procedure. Only in the case of metallic ruthenium nanoparticle, you need to use inert atmosphere.
Yeah.
And ruthenium oxide nanoparticles, definitely you can prepare in ordinary laboratory conditions.
So the raw material which we have used is the hydrated ruthenium chloride, right, sir?
No, that is normally used actually, hydrated ruthenium chloride, but we have used tris acetyl acetonato-ruthenium.
Oh, fine, sir. It's a complex compound, sir.
Yes, because in the case of copper oxide, copper and bohemite, we have followed the already available, we have just prepared based on the literature, and we have used as a catalyst. But in the case of ruthenium, we wanted to prepare a new material, so we used a new precursor.
Yes,
and we have got, a very good morphology, and we have got good activity also.
Yes, sir. Yes, sir. Thank you, sir. Thank you for your wonderful work and discussion. Thanks a lot, sir.
Thank you.
Thank you, sir. Any other participants from Zoom link? Okay, I can go for again charting bugs question, Professor.
Yes.
This question was asked by Dr. Revadi from Gongu Engineering College, Perundurai, Erode.
Yeah.
Sir, while we are preparing the copper nanoparticles, the pH range 6 to 9 only reported in the literature.
Yeah.
But the people, when they are using for the effective removal of pollutants, they kept the lowest pH around pH 2.5. Can you explain the reason why they are keeping this different pH?
No, when you remove pollutant, in most of the cases, they will not again reuse the material. No. So in that case, I feel that whatever nanomaterial or support they employ, it won't remain in the same state once the process completes. But in our case, we prepare the nanomaterial and we use in a reaction, and again we use it in further cycles, right? And so this maintaining pH is very important. But to prepare the material, to get the particular size of the material, the maintaining pH is very, very important. But in the case of this, what you call the pollutant removal and all, they may adopt, I mean, the material is already formed. No, they are not preparing the copper oxide. The material is already prepared by following this pH. But once the material is prepared, they employ some other pH for the removal of the pollutant. Even during the course of the removal of the pollutant, I don't know, maybe the copper oxide remains as copper oxide, or maybe it may be converted into something else. Anyway, they are going to throw it, that's all.
Okay, thank you, Professor. And this question was asked by Dr. Nageshwar Singh from Zoom link. What is the secondary alcohol oxidase? The question not completed. I guess he is asking about the secondary alcohol oxidase and give which product.
Yeah, so actually I think he's asking about the selectivity that we have done. We have taken both primary and secondary alcohols in equal amounts, and we have used some nanoparticles as a catalyst to see the selectivity of the system. In most of the cases, primary alcohols are oxidized preferentially to corresponding the aldehyde, compared to the oxidation of secondary alcohols to the ketone. And of course, the catalyst reactivity is one thing, and the acidity of the proton in the alcohol, that is also the another factor. But in some heterogeneous catalysts, they oxidize both the alcohols to the same extent. But when you use nanoparticles as a catalyst, only one alcohol is preferentially oxidized compared to the other alcohol. Now, in our cases, only the primary alcohols are preferentially oxidized compared to the secondary alcohol. So when you oxidize secondary alcohol, of course, you will get ketone. But if you have both primary and secondary, only the primary is preferentially oxidized compared to the secondary.
Okay, thank you, Professor. So those who are in a Zoom link participants, you can ask directly with our chief guest.
Hello.
Yes, sir. Yes, please.
Good evening, sir.
Yes, madam.
Sir, how ruthenium-based nanoparticles act as catalysts in organometallic compounds?
No. I tell you that ruthenium organometallic compounds are well-known catalysts for many organic transformations. There are many Nobel Prize winning ruthenium organometallic catalysts. That is different. I mean, any organometallic catalyst, mostly they are soluble in the solvent, so they are homogeneous in nature. They perform the reaction very effectively, but I told you in the beginning, it is very difficult to separate the product or to separate the catalyst at the end of the reaction. Because of that, even many efficient homogeneous catalytic systems, particularly based on ruthenium or some other noble metals, they cannot be commercialized. But when instead of organometallic ruthenium compound, if ruthenium nanoparticles are used as a catalyst, no, the efficiency of the reaction is maintained. Ruthenium nanoparticles also can catalyze the reaction with the same efficiency. At the same time, after the reaction, you can easily remove the catalyst. It means you can easily get the product in the pure form without any metal impurity. So that is the advantage of these metal nanoparticles compared to organometallic catalyst.
Okay, sir. Okay, thank you, sir.
Yeah.
Thank you, madam. And any other participants? Okay, Professor, this is my question. So, yes, please, sir. Yes, please.
Sir, my introduction from chemistry department, Crescent, sir.
Yes.
In copper oxide nanoparticle, if reusable, the percentage level is 100%, or it can be different, sir, if you reused means.
Yeah, so actually, I mean, in the first run, if the yield is 90%, the same 90% is maintained in the subsequent runs. Even we have done the experiment for 10 cycles. Maybe, I mean, there is I mean, it may come to 89 or 88, but not drastic decrease in the yield. Almost the same efficiency you can get when you recycle the copper oxide nanoparticles.
Okay, thank you, Professor. Any other question from participants' side? Okay, Professor. We know well if we are preparing gold nanoparticles, silver nanoparticle is highly stable, but copper nanoparticles, people are reporting it's not stable even for 1 month something. Can you comment on it and how we have to improve the stability?
No, we have also observed, copper oxide, there is no problem. But if you use maybe metallic copper or even the metallic ruthenium even, we have, I mean, you have seen that we have taken that XPS immediately after preparing. But even if you record XPS, you will see traces of copper oxide. So if you keep it in the atmosphere for a long time, definitely it won't. I mean, it won't remain as copper. It will become copper 1 oxide or copper 2 oxide. So the only way is you have to prepare the catalyst and use it immediately. I mean, that's how we do. Or otherwise, you have to store the catalyst in the inert atmosphere. By the way, you can avoid the oxidation of the metal.
Okay, thank you, Professor. Any other question from Zoom link participants? If no question, then we can go for the validatory function. Thanks a lot, Professor, for your excellent presentation. And on behalf of Department of Chemistry, B.S. Abdur and Crescent Institute of Science and Technology, and myself, it's our duty to thank you. Thanks a lot for your kind acceptance of our invitation, and you come over and deliver a very excellent talk during this pandemic period. Thank you so much, Professor.
Thank you, Dr. Asmali.
Yes. Aisha, ready?
Yes,
so,
sir.
dear
Yes,
participants,
sir,
now we are going to conduct the validatory functions. So, thereafter, we will send you the feedback form. So, the feedback form today, it will be valid for 1 hour. So, you don't need to worry. So, kindly request all the participants to stay here and kindly participate in our validatory function. Thank you so much. Now, I hand over the session to Aisha.
Thank you, sir, for a wonderful lecture. It was really nice work, and you have you have done the versatility of all the synthesized nanoparticles. I'm sure it was a benefit for everyone who heard your lecture. Now, let's move on to the valedictory function. For this, let me call upon our esteemed chief guest and speaker, Dr. R.Karvembu, sir, two conveners of this 14 days FDP program, Dr. S. Kutirani, ma'am, Professor and Dean, School of Physical and Chemical Sciences, and Dr. D. Ishramurthy, sir, Professor and Head, Department of Chemistry. I would also like to call the coordinator of this event, Dr. N. Vasimalai, sir, Assistant Professor, Department of Chemistry, for this valedictory session. Kindly join and unmute yourselves. Sir? Sir, Ishwar sir.
Yes,
Yes,
ma'am.
ma, you can.
Yes, yes.
Dean,
Yes,
madam.
proceed.
Ma'am.
So other co-hosts give admit. You can start, ma, no problem.
You can
Madam
start
is
with
there?
Gujarat.
Rani
Yes, sir,
ma'am.
I'm here. Yeah, I'm
Okay,
here.
madam.
Yes,
Can we
ma'am.
start
Aisha.
the validatory program,
Yes, sir.
sir and
Yes,
madam?
sir. Yes,
Okay,
sir.
Yes,
Yes.
thank you, thank
proceed.
you. Yes, ma,
Good
Aisha.
evening, once again, good evening to everyone. Now I request our Professor and Dean, School of Physical and Chemical Sciences, Dr. S. Kutirani ma'am, to deliver the welcome address.
Aisha,
Yeah, you are
Kirat,
start
Kirat.
with Gujarat.
Sorry, sir.
Aisha.
Okay,
Our
okay, sir, I inform her, sir. Okay.
Khatija.
Yes, Akka.
Now let's start the session invoking the blessings of our Almighty. For this, I request MSc student Khatija to deliver the Kirat.
أعوذ بالله من الشيطان الرجيم. Surah Fatiha, the opening. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alameen. الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغلوب عليهم ولا الضالين. Ameen. The translation. In the name of Allah, the most gracious, the ever merciful, all type of perfect, the true prize belongs to Allah alone, the Lord of the worlds, the most gracious, the ever merciful, master of the day of requital. You alone do we worship, and you alone do we implore for help. Lead us on the exact right path till we reach the goal, the path of those on whom you have bestowed your blessings, those who have not incurred your displeasure, and those who have not gone astray. Ameen.
Thank you, Khatija. Now I request our Dean, Professor and Dean, School of Physical and Chemical Sciences, Dr. S. Kutirani ma'am, to deliver the welcome address.
Am I audible, Aisha?
Yes, ma'am.
Okay. Very good evening to one and all present here. I am Dr. Kutirani, Dean for the School of Physical and Chemical Sciences from B.S. Abdur Crescent Institute of Science and Technology. On behalf of Chemistry Department of BSA Crescent Institute of Science and Technology, I welcome you all for the valedictory function of 14 days e-faculty development program on material science and nanotechnology organized by Chemistry Department of BSA Crescent Institute for 14 days from 3rd August to 17th August 2020. It gives me immense pleasure to welcome our respected chief guest of today, that is the final day of 14 days e-faculty development program, Dr. R.Karvembu, Professor, Department of Chemistry, National Institute of Technology, Trichy. He is kind enough to accept our invitation. Thank you, sir. I am very happy to welcome Dr. Ishwaramurthy, Professor and Head, Chemistry Department of our institute for his support and encouragement. I extend my warm welcome to Dr. Vasimalai, the coordinator of this FDP, for his meticulous and systematic approach in organizing this FDP. I also appreciate the efforts taken by him in identifying the eminent resource persons from various reputed institutions for this FDP. I extend a warm welcome to all the participants. I take this opportunity to thank the technical team comprising of our research scholars and second year MSc students for their teamwork and complete cooperation in successful conduct of this FDP. With these few words, I once again welcome you all for this valedictory function. Thank you.
Thank you, ma'am. Now I request a coordinator of this FDP program, Dr. N. Vasimalai sir, Assistant Professor, Department of Chemistry, Selection Grade, to read the report, overall report of this FDP session.
Very good evening to all. So very good evening to one and all present here. It is my immense pleasure to read the report of 14 days faculty development program on material science and nanotechnology 2020 organized by Department of Chemistry, B.S. Abdur Rahman Crescent Institute of Science and Technology, Vandalur, Chennai 48. The major theme of this program is to make superior improvement of nanotechnology and material science research to reach new heights. The main focus of this FTP MS MNST 2020 was to help the faculties in betterment to understand and explore innovations and to know the more on current research trends in nanotechnology and material science and to spread awareness about the value of nanotechnology and material science. This is our prime theme. Then initially we have started our work. Then so initial idea of a program is to conduct a 2 weeks event, and I approaches the eminent speakers, various part of India. All are my known circle only. And also I thought that to cover throughout the India. If you see our brochure, then I just bring some person from Punjab, Kashmir, and today's speaker from South Tamil Nadu, as well as North, South, East, West, and middle part of India. I have covered, and I bring the eminent speaker. And the major highlight of the speakers, all the speakers are from IITs, NITs, IISER, Central Universities, and Central Funded Research Institutes only. So also every speaker's topic was specially concentrated. I just thought that to give a different title to cover throughout the material science. So if you see our brochure, again, I just framed on the aim of cover all the disciplines in science, material science, agriculture, engineering, biology, medical science, etc. So we have posted our invitation just 4 days before of our event only throughout the India. We just took top 10 colleges, top 10 universities, top 10 private universities in each state. Fortunately, we got 1,500 participants registration throughout the India. And of course, we are not send the invitation to abroad through their circle. Then we have received overseas participants also from various countries. I can go one by one. Fortunately, we got participants from principals from several colleges, directors, chairmen, managing directors, and deputy managers, head of the departments, professors, associate professors, assistant professors, and researchers from various parts of India. Almost we covered, we have participants throughout the Indian state. For examples, I don't have a time, I can read one by one. So the principal from Talai district Polytechnics, Tripura, and this principal from DMI, Yugan University, Malawi, it's a Southern Africa, foreign participants we have received. And the principal from SS College, Jehanandabad, Bihar, and Union Christian College principal from Meghalaya, Paba Sarwan College from Kurukshetra, and National University of Chemistry, Europe, the visiting scientist, Slovenia. So these much principals and directors from several research institute, as well as director from Center for Nanoscience, Nanotechnologies from various parts of India, Indian universities we have received. And we have covered around 25 states of the country. The participants we have received from Andhra Pradesh, Arunachal Pradesh, Assam, Bihar, Chandigarh, Delhi, Goa, Gujarat, Haryana, Himachal Pradesh, Jammu Kashmir, Jharkhand, Karnataka, Kerala, Madhya Pradesh, Maharashtra, Meghalaya, Pondicherry, Punjab, Rajasthan, Tamil Nadu, Telangana, Tripura, Uttar Pradesh, and West Bengal. Almost we have a participants in all the states. Moreover, we have received the overseas participants from Malaysia, South Korea, then Malawi, Southeast African country, and Qatar, Taiwan, Muscat, Saudi Arabian participants. Of course, we are not sending the invitation to them, but they have registered. It is warm welcome. And through that way, we have overseas participants also. Now let's read the short report of each day program. First day program FDP MNST 2020 was successfully started on 3rd August 2020. The speaker, Dr. Rajkumar, Director, Indian Rubber Manufacturer Associations. He has delivered the inaugural talk and he just proposed a talk on the topic of advances in polymer technology. He has highlighted the opportunities of rubber industries. Then he explained about the advancements of polymer technology. Then second day talk was delivered by Professor Dr. N. Sandhyarani, School of Material Science and Engineering, National Institute of Technology, Kerala. Her topic is nanomaterials-based platform for biosensing application. The speaker initially covered the fundamentals of nanoscience and nanotechnology and their applications. Then she focused on biosensor and their sensitivity, selectivity, etc. Day 3 talk was given by Dr. A. Pandikumar, scientist, Materials Electrochemistry Division, CSER SICRI, Central Electrochemical Research Institute, Karaikudi, Tamil Nadu. His topic, heterojunctions photocatalytic materials for photochemical water splitting applications. And he discussed the recording of the utilization of solar energy, and he discussed the harvesting of conversion of solar energy from the nature, etc. Then day 4 talk was given by Dr. S. Abraham John, Director, Center for Nanoscience and Nanotechnology, Department of Chemistry, Gandhikaram Rural Institute, Dindigul, Tamil Nadu. His topic was carbon dots for optical electrochemical sensing application. The speaker discussed about the research activities done by his research group, and also he has given very good explanation about the carbon quantum dots from the fundamental to advanced level. Then day 5 was handled by the speaker Dr. M. Sankar, Associate Professor, Department of Chemistry, Indian Institute of Technology, Roorkee, Uttarakhand. His topic was material applications of farfiring. The speaker started his talk giving the importance of functionalization of farfiring and the hemes. Then he discussed about the vitamins, chlorophyll and their functionalities and the material applications, etc. Then day 6, the session was handled by Dr. Bikash Kumar Shena, Principal Scientist, Materials Chemistry Department, CSER, Institute of Minerals and Materials Technology, Bhubaneswar, Odisha. His topic, nanomaterials for energy conversion application. The speaker briefly explained about the synthesis and applications of graphene material, and he has covered the fundamentals of HER, OER, and its challenges, limitations, etc. Then day 4 talk was given by Dr. Manorama Singh, Assistant Professor, Department of Chemistry, Guru Ghasidas Viswavidyalaya, Central University of Chhattisgarh. And her topic, functional graphene nanomaterials for electrochemical sensor technology. She has discussed about the sensor based on the graphene materials and its advancement and electrochemical applications, glucose sensor, biochips, etc. Then day 8 was handled by Dr. Siri Sivakumar, Professor, Department of Chemical Engineering, Indian Institute of Technology, Kanpur, Uttar Pradesh. And his topic was nano-engineering materials for biological applications. The speaker briefly explained about the importance of nanotechnology. He mainly focused on the polyethylene glycol, pegylated carbon nanoparticles, and PDMS and its applications. Then day 9 was taken over by speaker Dr. P.S. Vijay Kumar, scientist, Institute of Nanoscience and Technology, and Autonomous Research Institute of Department of Science and Technology, Government of India, Mogali, Punjab. His title, Recent Trends in Agriculture Nanotechnology. He discussed the fundamentals of the nanoparticles and its advancement and its applications related with agriculture field. especially the targeted drug delivery system he discussed in a well manner. And day 10 talk was given by speaker Dr. C. Ratnaraj, Professor, Department of Chemistry, Indian Institute of Technology, Kharagpur, West Bengal. His topic was functional materials for electrochemical energy storage devices. His talk started with stressing the global economy and the global energy demands. Then later he covered the fundamental aspect of electrochemistry and explained the day-to-day applications. And he has given the very good short story of historical slight light of science and era Remsen's title Nitric Acid upon Copper. And the day 11 session was handled by speaker Dr. K.V. Gobi, Professor, Department of Chemistry, National Institute of Technology, Warangal, Telangana. His topic was hybrid nanocomposite materials for electrocatalytic applications in sensor. SAR was discussed about the various types of multi-walled carbon nanotubes based materials and their reduction in the cancer drugs as well as other drugs. And day 12 was taken over by Dr. M. Venkataramanan, Professor, Department of Chemical Science, Indian Institute of Science and Technology, IISER, Kolkata. And the topic is lanthanum-doped luminescent nanocrystal synthesis and their applications in lighting detection of photocatalysis. He has highlighted the characterization and synthesis part of the lanthanum-doped nanoparticles and its advanced research. Then day 13 was talk was given by Dr. S. Nagarajan, Assistant Professor from National Institute of Technology, Warangal, Telangana. His title was Soft Materials by Molecular Self-Assembly. He explained about the self-assembly and gave some examples of natures and its living organisms form the DNA, and he discussed many things about the advanced research for the disease engineering and the wound killings applications. Then final talk today was given by Dr. R.Karvembu, Professor, Department of Chemistry, National Institute of Technology, Trichy, Tamil Nadu. And his topic was nanomaterials in catalysis. Sar has explained the fundamentals of catalysis, heterogeneous, homogeneous catalysis, and discussed about the recent research in the catalysis using nanomaterials. Moreover, the speaker has been highlighted his lab research outputs. So people behind this FDP success, the program was grand success. This was achieved by because of the fullest support of our Vice Chancellor, Pro Vice Chancellor, and the Register, who encouraged and support us to conduct this program. Then the constant support from our beloved Dean, Dr. S. Kutirani Madam, School of Physical Chemical Sciences, and Professor Dr. D. Iswaramurthy, Head of the Department, Department of Chemistry, Crescent, PS Abdur, Crescent Institute of Science and Technology, and students committee members. Of course, it's my privilege to thank all the faculty members from Department of Chemistry, Dr. N. Hajara PV, Dr. S. Bhagavati, Dr. Revadi Purushothaman, Dr. Sajagan, Dr. Supan Kumar Das, Dr. Herbert Mabel, Dr. Asha Jansi, Dr. Noor Dr. Vajravel, Dr. Karthikeyan, Dr. Rafiq, and Dr. Sagila. My special thanks to Dr. Senior Professor Dr. N. Hajara Bibi. Madam has given a vote of thanks during our inaugural address, and other faculty members for their direct and indirect support and constant encouragement. And also I thank our non-teaching staffs of our Department of Chemistry, PS Abdur, Crescent Institute of Science and Technology, for their backbone of these 14 days FTP MNST 2020. I thank all the speakers and the participants for their fullest support and encouragement. The supreme reason for this great success of these 14 days FTP MNST 2020 is the speaker. So from various institutions, and they were accepted my invitation because of their love with Crescent people as well as my friendships. And also we are not giving any honorarium for them. So they just come for our friendly request and spend their valuable time with us and deliver a very nice talk. And I hope that this talk definitely it is useful for you. By God's grace, the program was well conducted and come to the end with all your support. I hope every participants were benefited. I request everyone to support us as such for the further event. Thank you all.
Thank you very much, sir, for briefly elaborating about the sessions. We are indeed highly indebted to all the speakers who have actively engaged us all throughout these 14 days. Now I request a professor and head of the Department of Chemistry, Dr. D. Ishamurthy sir, to deliver the vote of thanks. Sir?
Vasimalai?
Sir, it is audible, sir, please.
Audible. Before that, you said you want to collect the feedback, online feedback.
Okay, Aisha. So now I request the participants, those who are in a Zoom link, you just unmute by yourself and give the overall feedback of 14 days event. And whatever you want to say, please register your feedback. Abhilash Vengat, kindly give the option to unmute by themselves. Sir, please tell your name and where are you from. So briefly give your feedback.
Good evening to all. This is Dr. Shiny John Weideman from Stella Maris College. I take this as an honor and a privilege to express my feed of thanks. Can you hear me, sir?
Yeah, it's audible, madam. Please carry on.
Okay. Yeah, yes, sir. So I would like to express my sincere gratitude. This 14 days faculty development program on material science and nanotechnology, FDP MS NT 2020, have provided for us participants a ladder of opportunity and also an investment in the future of the world, in the words of Ed Markey. I thank the organizers of FDP MS NT 2020 for giving me this opportunity to express my feedback. At the outset, let me congratulate the Department of Chemistry BS Abdur Rahman Crescent Institute of Science and Technology for conducting the 14 days FDP Material Science and Nanotechnology 2020. I wish to appreciate the hard work and team efforts of Dr. Vasimalai and organizing team for the meticulous planning and execution for the successful conduct of the program. Dr. Vasimalai has coordinated with the support of Dr. Kuttirani ma'am and Dr. Ishwari Murthy and the administrators, and has networked very well to ensure that he gets speakers from esteemed national institutes like NIT, IIT, IISER, INST, Indian Rubber Research Associations. He has also ensured to get resource persons, eminent scientists from local, regional, and national, Uttarakhand, Odisha, Chhattisgarh, UP, Punjab, West Bengal, Telangana, Kolkata, Tamil Nadu. So with such rich expertise and eminent scientists from varied fields of material science and nanotechnology, this FDP encompasses varied applications of material science, such as catalysis, photocatalysis, photochemical water splitting, optical and electrochemical sensing applications, porphyrin applications, polymer, biosensing, energy conversion applications, biological applications, and agricultural nanotechnology. I would like to thank for providing sufficient time by the coordinator for the question and answer session, providing opportunity to participants, one question for every feedback, to ensure that the participants engaged during the webinar. I agree with the quote of Elie Metchnikoff. Science is said, no doubt, has ameliorated the material conditions of the human life, unquote. So we have seen a plethora of examples of the utility of nanomaterials and materials in day-to-day life to solve problems with respect to environmental degradation, enhance sustainable energy, high catalytic activity, wound healing, health living, cost-effective technology. The webinar series also highlighted the various characterization techniques for the researchers. I am inclined to envisage this FDP MSNT 2020 to an analogy as follows. The virtual platform webinar as the reaction vessel, the reaction matrix as the participants who were actively involved and engaged in this reaction, the catalyst, Dr. Vasimalai and eminent scientists, the organizing team as the nanoparticles, the experimental conditions as the A.S. Abdur Rahman Crescent Institute of Nanotechnology, the administrators, dean and HOD, the technical moderators as the chiral ligands to get the specified yield of the products. Thus, at the close of the reaction, namely FDP MNST 2020, has churned out participants, academicians, and researchers as fluorescent materials to give the absorbed energy of knowledge and skills for the benefit of the society via sharing knowledge to students and colleagues or through active research. In short, the series of lectures facilitated to enrich theoretical knowledge and opportunity to update with recent trends in material science and nanotechnology. Thank you once again, the administration, Department of Chemistry, and especially the organizing team for the success of the program. I conclude with the words of Dr. APJ Abdul Kalam. Education is the most powerful weapon which we can use to change the world. And I quote Malcolm X, education is a passport to the future, for tomorrow belongs to those who prepare for it today, unquote. Thank you very much for the opportunity given to me. Shiny John Byerman from Stella Maris College. Thank you.
Thanks a lot for your excellent feedback, madam. Now, Dr. C.L. Monica, she is raising her hand. Madam, you can.
Yes, sir. Good evening to all. Sir, I'm audible?
Yeah, you are audible. Yes, please.
Good evening to all. I'm so grateful to all the organizers, especially to you, sir. Every day we see right from 14 days and your team, and to each of the speaker, because each speaker has given great contributions. They have discussed in detail all their work and they have given us new ideas. And your positivity and encouragement brightened all our days, all the 2 weeks. And this platform has made me a better person and a more thoughtful person. So I look forward for various other from your end as well in future. And dhanyavad. Thank you, sir.
May I know where are you from, madam?
I'm from Andhra Pradesh, sir, Vijayawada. I'm from a small village, Penamaluru.
Okay, madam. Thank you. Thank you so much for your feedback. Any other participants, please unmute your mic and you just register your feedback.
Hello, sir. Hello, sir.
Yeah, yes, sir. It is audible. Yes, please.
Sorry. Oh, okay. So, good evening, everybody present today. First of all, I would like to thank the organizers, the chemistry department of B.S. Abdur Rahman Crescent Institute of Science and Technology, and congratulate them for successful completion of this 14 days program. I am Dr. Pankaj Datta. I am an associate professor at Department of Physics, Dibrugarh University, Assam. In fact, it is the most easternmost university of India. This is a state university. To be frank, earlier I had actually no idea about your institute. So now, after this program, I will carry a very good impression about your very esteemed institute. So on our next occasions, definitely we will try to contact you, sir. This is in fact a very nice experience. The last 4 days have been exceptional. So many great personalities sharing their very vast knowledge, experience. All were very nice. But for me, the lectures from C.R. Raj sir, Abraham John sir, they were truly exceptional and exciting. We could experience very skilled leadership of Dr. N. Vasimalai sir and very dedicated supporting hands from many research scholars. The efforts were truly professional. So I hope it would have been nicer to enjoy one lecture from Vasimalai sir. So yeah, so I am sure all the participants will carry very good memories and experience from this program. I congratulate the organizers once again for their very successful completion of this very important event in this pandemic, and wish them all a very great success for future. And I also request them to try to remember Dibrugarh University, Assam. So I will, yeah. Thank you very much, sir, for your very kind effort and skill leadership. Thank you,
Okay, sir. Thanks a lot for your excellent feedback, sir. Now I have seen the one hand from Dr. Krishnamurthy. So, sir, please, you can give. So those who want to give a feedback, please raise your hand. Thereafter, we can give the priority. Krishnamurthy, sir, please.
Yes, sir. Yes, sir. Thank you, Dr. Vasimalai, sir, for giving me this wonderful opportunity in this platform. Very nice. Good evening to one and all in the 14-day faculty development program on material science and nanotechnology from 3rd to 17th August 2020 in the Department of Chemistry, B.S. Abdur Rahman, Crescent University. I am Dr. P. Krishnamurthy, faculty member from the Department of Chemistry, Dr. Abdur Government Arts College, Vyasarpadi. On behalf of our department and my own behalf as an active participant in the past 14 days, I heartily congratulate the Crescent management and the authorities and convener and dean, Professor Kuttirani ma'am, HOD and convener Iswaramurthy sir, and the effective and active young chap coordinator, Dr. Vasimalai sir, and all the faculty member and research scholars, PG students, and all other organizing committee members for arranging such a wonderful high standard FDP MSNT 2020 program. This 14-day marathon is well organized and arranged with high quality, excellent resource persons with the informative discussions. As a beneficiary and also as an active participant and also as a faculty member, I extend my sincere thanks and congratulations and my felicitation to the entire eminent speaker and scientist from the Indian various IITs, ISR, NIT, Central University, and Central Funded Research Institution. We really very much delighted, sir, and enriched our knowledge from the 1 to 14th day program. In the day 1, Dr. K. Rajkumar, sir, excellently given the polymer nanocomposite discussion, and day 2, Sandhya Rani ma'am is biosensing applications, and day 3, Pandit Kumar sir's photocatalytic material discussion, and day 4 is Abraham John sir's carbon dots and electrochemical sensing applications, and day 5 Dr. M. Sankaran sir's porphyrin applications, and day 6 Dr. Vikas Kumar Jana sir's nano energy conversions and applications, day 7 Dr. Manorama Singh ma'am's graphene nanosensing technology, and day 8 Dr. Sivakumar sir's nano bio application, Sri Sivakumar sir's nano bio applications, day 9 Vijay Kumar sir's agricultural nanotechnology, and day 10 Dr. C. Ratnaraj sir's functional material and energy storage, day 11 Dr. K.V. Kopi sir's hybrid nanosensing applications, and day 12 Dr. M. Venkatraman sir's study of lanthanide doped nanoparticle, day 13 Dr. S. Nagarajan sir's soft material by molecular self-assembly, day 14 Dr. N. Today, the eminent talk given by our excellent Professor Dr. R.Karvembu sir, copper oxides and its nanomaterials in catalysis. So really this program is very wonderful and very useful for all the academic community. This program is really well organized and highly systematized. It's very systematized. I assure sir, we faculty members and the research scholar, really we attained immense knowledge in this faculty development program. Usually universities are arranging some faculty development program for 3 or 4 days, but for the days they may fix the registration fees for minimum of 500 or 1000 rupees. But without any registration fees, 14 days, the continuous marathon given by the Crescent University. Hats off to this university and the excellent member. Really, it's a teamwork. I really congratulate all the faculty members in the department and the research scholars, how wonderful their contributions to make a grand success of this program. It's really a mightiest academic contribution for the young researchers, sir. Thanks you very much. Thanks a lot for your wonderful opportunity, sir. Thank you very much.
Thanks a lot, Krishnamurthy sir, for your excellent feedback. The participants, please kindly give a brief feedback because we have to give the opportunity to others. Now I have seen the Rama Devi is raising hand. Please, madam, you can.
Yes. Good evening to all. I am Rama Devi, Assistant Professor from VSS Government Arts College, Pulanguruchi. It is my privilege and honor to share the feedback on this occasion. First of all, I thank you very much for the organizing team for providing a well-organized 14-day FDP. So in this program, all the research persons are eminent speakers. They delivered an excellent speak on various topics. I hope by this FDP, the participants will surely enrich with current trends in research in various fields. So here, all the sessions are informative, excellent, and interesting one. My heartfelt thanks to the coordinator, Dr. N. Vasimalai, for his promptly and patiently holding the program to a great success. ஸோ மனம் இருந்தால் மார்க்கம் உண்டு அப்படின்னு சொல்லுவாங்க. அதுக்கு ஏற்ற மாதிரி எல்லாரும் 3 days 4 days இந்த ப்ரோக்ராம் கண்டக்ட் பண்ணாலும் 14 days எந்த ஒரு டிஸ்டர்பன்ஸும் இல்லாமல் எல்லா பார்ட்டிசிபென்ட்ஸுமே வந்து ஒரு இன்வால்மெண்ட்டோட இந்த ப்ரோக்ராம் வந்து நீங்கள் வந்து கொண்டு போயிருக்கீங்க. ஸோ அதுக்கு உங்களோட காலேஜ் தென் டீன் உங்களோட பிரின்சிபல்ஸ் ஃபார் ஆல் த ஃபேக்கல்டி மெம்பர்ஸ் and all the organizing team, once again I congratulate. Thank you, sir.
Thank you, madam. So any other participants, please unmute your mic and talk.
It was just wonderful, wonderful, and wonderful. I am Dr. Sharat Tajne from Bhavans College, Andheri, Mumbai. For so long, that is 14 days program, and arranged in a very systematic manner without any technical hatches. I just wish you all the best and let me know your next move for such.
Thank you. Thank you so much, Professor. Okay, and for the participants' information, so we also handle all the participants in a nice manner because we have given the priority as well as we respect to your position. So if some participants, if they are missing the feedback form, next day if they are asking, definitely we send that feedback form. And some faculties they miss for event due to the network poor connections, and also we just accepted their request, and the maximum possibility how much it is there, that much reply we sent. So through email, through WhatsApp, and many participants just call me and encourage me directly. So thanks a lot for your fullest support, participants. So we will be see in another one programs. Definitely we will be in touch with you. And thanks a lot for your feedback. Now I hand over the session to Aisha.
Really, once again, I thank all the audiences. Your wonderful feedbacks and comments only keeps us ongoing and ups up our hopes and spirits. Now I request Professor and Head, Department of Chemistry, Dr. D. Ishramurthy sir, to give the vote of thanks. Sir?
Okay, dear Dr. R.Karvembu, Professor, Department of Chemistry, NIT Trichy, dear Dr. S.K. Rani ma'am, Dean School of Physical and Chemical Sciences, dear Dr. N. Vasimalai, Assistant Professor, Selection Grade of our department and the coordinator of this 14-day faculty development program on material science and nanotechnology, and dear participants, my dear colleagues, research scholars, and dear students. Good evening to one and all. With immense pleasure, I, Dr. D. Ishramurthy, Head of the Department of Chemistry, B.S. Abdur, Crescent Institute of Science and Technology, proposing the vote of thanks for this 14-day faculty development program. We are very much thankful to all our resourceful and eminent persons from reputed institutions who have delivered an informative and elaborate lecture on the various domains of the applications of nanotechnology. Our sincere thanks to Dr. R. Rajkumar, Director, IRMRA, Maharashtra, Dr. N. Sandhyarani, NIT Kerala, Dr. A. Pandikumar, Secretary, Karaikudi, and Dr. Afragam John, Kandigram Rural Institute, Dr. M. Venkatraman, IISER, Kolkata, Dr. Vikas Kumar Jena, IMMT, Bhubaneswar, Dr. Manonama Singh, Guru Vasudas Vishwavidyalaya, Dr. Sri Shivakumar, IIT Kanpur, Dr. P.S. Vijayakumar, INSC Mohali, Dr. C. Ratanraj, IIT Kharagpur, Dr. K.V. Gobi, NIT Warangal, Dr. M. Sankar, IIT Roorkee, Dr. S. Nagarajan, NIT Warangal, and Dr. R.Karvembu, NIT Trichy. Hope the participants are enlightened and enriched by this faculty development program. I thank the Almighty who has showered us with his blessings for all the 14 days without any delay. I am thankful to our Pro Vice Chancellor, Registrar for their support, motivation, and encouragement to conduct this type of program. I thank our school dean, Dr. S.K. Rani, for the guidance. My special thanks to Dr. N. Wasimalai, coordinator of this faculty development program, though it was conducted first time for our department in a meticulous way of planning and successful execution of this program. I thank my colleagues who have contributed directly or indirectly for the successful conduct of this program. My special thanks to our scholars and my dear MSc students for their exemplary leadership qualities by taking care of on-stage activities. Without their support, the program could not be successful. I thank all the participants who are so punctual in all the 14 days and for their lively interaction with their resource person. Thank you, one and all. Thank you.
Thank you so much, Ishwar sir. Yes, ma.
Yes.
Thank you very
Yes,
much,
Aisha,
sir.
please.
Thank you very much, sir, for giving a wonderful conclusion of our 14 days FDP program. Sir, can I give instructions to the
Yes,
participants?
please. Yes, please.
Sir, welcome.
Yes, sir. So, participants, thank you everyone, first of all, for your kind patience in waiting and listening to our valedictory function. And thank you one and all for active participation in all these 14 days. I just want to give you some instructions. We have received around 1,500 participants for this event from diverse regions of our country. The learning fraternity members from different central and state universities have registered. So we'll provide you your certificates as early as possible within 5 days. So kindly take care while filling the feedback forms, and please, if there's any issue or further delay, you can mail us at our given registered mail ID. Please kindly cooperate.
This is for participants' information. Again, I am giving the detailed information. So we will create the e-certificate for you. If you are receiving any email from us, kindly fill the details. We will ask you to fill your name, designation, institute ID. Thereafter, e-certificate automatically can create. Each day we have a limited number of certificates only. So please give me a 5 days time for us. Even if you are not receive any certificate or any communication from us until 23rd of August, it means that coming Sunday, then please contact us. So don't contact us before 5 days. These 5 days time it's needed for us to check the attendance and other things. If the participants, if you are missing to fill the attendance, already we have received the mail and we will consider your request. So feel free to contact us in case if you are not receiving any certificate after 23rd of August. And we will be active in Facebook, WhatsApp as well as email. So feel free to send your complaints, other things. Definitely we will solve your issue. In case of any spelling mistake, something it is happened, that one also we can consider your request. By request, then we will rewrite your certificate and we will send to you. So kindly give us 5 days time to post your certificate. So slowly we are doing, and it's a very big work to check all the 14 days attendance. Hope you understand the situation. Kindly cooperate with us. For any other assistance or help needed from us, feel free to chat with us, or otherwise you can call me. Otherwise you can drop a message. Thank you so much.
Thank you, sir.
Dr. Wasimalai.
Yes, sir. Yes, please, sir.
Finally, we can take one screenshot with all our active group members.
Yes. So dear participants, we are going to take one screenshot photographs. So please unmute your video so that we can take one screenshot. It is our kind request. Please unmute your video. So participants, please unmute your video. We are going to take one screenshot. Abhilash Vengat, get ready. Give some times. Thereafter, you just.
Yes, sir. I'm ready, sir.
Yourself also unmute. Our students also unmute. And our faculty members also please unmute your video. Krishnamurthy sir, Shivashankar Prasad, Lakshmi, Kindly unmute. It is our small request, please. So Venkat, please take in the different views. Okay. So start to take. Katish also, Lakshmi, Shiny madam, Shiny John madam, please unmute your video, please.
Yes, those who yes, sir, almost taken, sir.
Take 2-3 photographs, no problem.
Okay, sir, I have taken it. Okay. Thank you so much.
Thank you so much, participants. So please unmute your video. Thanks a lot for your cooperation.
Thank you, one
Thank
and
you
all.
so much, participants. So please unmute your video. Thanks a lot for your cooperation.
Thank you, one
Thank
and
you
all.
so much, participants. So please unmute your video. Thanks a lot for your cooperation.
Thank you, one and all.
Participants.
Rasimale, sir, we can't hear you, sir.
Yes, sir. Unmute yourself and speak, sir.
I'm sorry.
Vasimale, sir, the video is not on by the host, so we cannot switch on our video.
Oh, yes, madam. Venkat, please give the option to unmute the video.
Sir, Vasimala, sir.
Yes, please, sir. Venkat, meanwhile, you just take a screenshot.
Okay,
Thanks a lot
sir.
for your
I
excellent
have...
feedback, Shiny madam. Okay, madam. Yes, sir.
Vasimala, sir.
Yes, please, sir. Please talk, sir. Yes, sir. Is it audible?
We can hear you, sir.
Vasimala, sir.
Yes, sir. Yes, sir. Please continue, sir.
Yes, you are audible, please.
Yes, sir. Please continue, sir.
Yes, other participants, if you want to give a feedback, you just unmute your mic. We are ready to listen your feedback. So if people want to leave from this meeting, kindly leave it, no problem.
Sir, Vasimala.
Yes, sir. Mohammed, sir, you are audible.
Muhammad, sir, Dr. Talimur, sir, you are audible, sir. Please continue.
Some echo problem is there. Okay.
Yes, sir.
Sir, please rejoin with us. We will be in online only.
Hello.
Yes, sir. Mohammed, sir, thank you for your valuable force. Thank you.
Okay, madam. Other participants, we already taken the sufficient photographs. Thanks a lot. You just unmute your mic and video, no problem.
Hello.
So in case if you want to give a feedback, we are ready to listen your feedback. Kindly unmute your mic and give your feedback. Yes, sir. Somebody is talking. May I know who's this?
Hello. Good evening to all.
Yes, sir. Yes, please, sir.
I'm in Telangana, lecturer in chemistry.
Yes, sir. Yes, please.
Hello.
Sir, your mic is not unmute. Please unmute your mic. Lakshman Sastri, sir.
Lakshman, sir, please unmute your mic. Thank you, sir.
So good evening to all participants and team, sir. So I am Nanoparticle Government Polytechnic College, Nizamabad district, Telangana state, sir.
Yes, sir. Yes, please.
So very thankful for organizing team, sir. In our 14 days working as very good information for in our nanotechnology and material science, sir. So thank you one and all, sir.
Okay, sir. You are welcome, sir. And also we are working in the nanotechnology field. So many faculties from our university we are working. In case if you want to make a future collaboration, you just join with us, sir. Yes, sir. Hussain, sir, please talk, sir. It's audible, sir.
Hello.
Yes, sir. Yes, please.
Sir, Vasimalai sir, very good webinar, sir, for 14 days. I enjoyed a lot, sir.
Thank you, sir. Thanks a lot for your full support. And every day you ask a lot of questions, and you also encourage our students and myself, sir.
Sir.
Thank you, sir.
Sir, for your information, I got doctorate from Alagappa University, Karaikudi, sir. I like Karaikudi very much, sir.
Oh, great, sir. Great, sir. From whom, sir? Who is your supervisor, sir? May I know?
Dr. S. Mohan, sir. S. Mohan.
Oh, okay, sir. Great, sir. Great, sir. Any other participants? Yes, please, sir. Yes, sir. Yes, sir. You can. Okay, sir. Every day I have seen you just came around 3:30, and you just after we leave only you.
Okay,
left.
okay.
So thank you so much, sir.
Okay, sir. Okay, sir. Vasimalai, sir. Thank you, sir.
So any other participants, if you want to give a feedback, just give. No problem.
Sir?
Yes, sir. Yes, please.
Thank you, sir. I'm Krishnamurthy again, Dr. Krishnamurthy.
Yes, sir. Yes, sir. Please, sir.
What are the instrumentation facilities available there, sir, for characterization and all?
Our head of the department is there, sir. Sir, please, sir.
Okay.
Yes, what is your question?
Yes, sir.
What are the instrument facilities we have it at our laboratory?
Sir, Professor Eswaramurthy, sir, I am Dr. Krishnamurthy from Dr. Ambedkar Government Arts College.
Okay.
I know you very well, but maybe you don't know me, but I know I heard you and Kutirani ma'am very well.
Sir, Eswaramurthy, sir, all over people.
Yeah, he's
the India popular.
Indian star. Yeah, that I know.
I think our friend Ramachandran is also working there.
Yes, sir. Correct. Ramachandran sir is working with us.
Okay.
Okay,
Yes, sir. Actually, we have UV visible spectroscopy, sir. UV visible spectrophotometer.
Okay.
And spectrofluorimeter.
Okay.
And we have IR. We have
XRD,
yes, sir.
XRD.
No, we don't have XRD. We are planning to purchase. We don't have XRD.
Yes, sir. Okay, sir. Okay. So our students, two or three students are doing under me, sir. If any help, then I'll send you, sir. Please you help us.
Okay. XRD after getting, I will inform you. But we have electrochemical system. So electrochemical studies.
Okay.
Vasimalai is in charge for that one.
Okay, sir. Sure.
For anything, you can approach us. No problem. We are there to help you.
Okay, sir. Thank you, sir.
So we will have a consultancy service as well as collaboration. If you do it, then that part also is available, sir. You just contact our HOD. It's again the information to the participants. Just to have a look of our website. So consultancy service we are doing. In case any emergency, if the paper come for revision something, then we will consider your request immediately. We will help you with whichever the instrument it is there at our laboratory. We are giving that service, sir. So you just contact directly our Dean Madam or HOD sir through mail or phone call. They will arrange the person to help you, sir.
I send my students there, sir. And
no
they
problem.
Come and meet you. Yeah, really.
No problem.
Thanks a lot, sir. You know very well about our government system. We have lack of instrumentation, but anyhow we have very good impacted journal. More than 35 journals, among that 25 journals are highly impacted journals we have. But even though the instrumentation there is a lacking. So you people say just to help us means really our students may grow. Thanks a lot.
Sure.
I will help you, sir. You send the student. No problem.
Yes, sir. Thank you very much, sir.
Thank you, sir. Any other participants wants to give a comment, please? Okay, Venkat, YouTube live is going on, or you stopped earlier?
Yes, sir. I'm stopping it, sir.